Hi everyone, welcome to my presentation of the KaggleX project. My name is Toshiki Kono from Japan. For my quick introduction, I'm a psychiatrist and clinical psychologist in Japan. I'm an associate professor of psychology at Okayama University. My specialty is here. In the process of my lecture, I noticed that although there is a lot of information about mental health issues, it becomes more complex and obscure to access common sense and consensus for a specific condition. That situation may lead to more stigma and make our therapeutic relationship worse in the future. On the other hand, specialists for the conditions generally share the standard thought through their effort and education, while service users find it challenging to know the shared understanding. As a clinician, I'd like to focus on making a therapeutic relationship rather than just providing basic information, especially at the beginning of my therapy. So I seek a convenient and quick way to show the specialist consensus to my client during treatment without biased information as much as possible. Generally speaking, the closer our information is to common sense, the more difficult it is to reach the resource and clear understanding. That characteristics of common sense would generate the next question. If the question is appropriate, this leads the next action to solve a problem. However, if not, the question may lead the next suspicion related to stigma. Therefore, my idea is to use LLM for common sense and compute guidelines data to track the origin of standard directions for treatment of the condition. To do that, I have selected RAG because we can easily update the resource. That means we can make an effort to clear the original data. At the same time, I use Occupy Best Match 25 and cosine values of vectorized query and resource sentences as retrievers following. Here is a diagram of my basic idea. For my first project, I chose depression as the most eligible psychiatric disorder to my project and collected guidelines for depression. In order to pull as many resources as possible, I chunked the original text based on token limits. Then I calculated a value called question resource value following the computation of two vectors cosine and Occupy BM25. I showed the mass of QRV here. Afterwards, I retrieved the appropriate chunks as RAG using LangChain and QRV. In this trial, each dot represents a chunk within 520 12 token limits. You can see the floating point with red or yellow color, which has higher QRV. The curve of the QRV graph looks more skewed than Occupy BM25 or the sign of two vectors only. That means QRV contrasts with covered chunk and other, even if either Occupy BM25 or the sign of two vectors independently show the gradual curve of the samples. After picking up and retrieving the chunks into prompts for a text generation of LLM, we can get the sample answer. Here is a sample of the answer in what standard up following the previous question. It seems less affected by marketing and the user conversation without RAG. I am creating a GitHub project for this app and everything is going well. Finally, I'd like to acknowledge my research advisor, Professor Darmani, for their invaluable guidance and support throughout this study. Thank you for your listening. I would be happy if someone were interested in my project and we collaborated in the future.